Lesson 3, topic closures. Go, go, go! Welcome to Skinning the Snake. Get your sharpest scalpel and... you know the drill. You should know by now that null functions are just functions. Remember generators? Yeah, the ones with yield. And who of you knows about coroutines? Functions defined with async. Closures are yet another kind of function. This one has something called free variables in its definition. If you haven't heard about this term...
I haven't. Most people haven't heard of those free variables.
Hey. Before we get to free variables, let's first see what other kinds of variables can a function have. When you assign to a new variable within a function, you expect that variable to live within that function's scope. That is, to be accessible within that function and nowhere else. Those are local. Be careful. Even at this point, things can get tricky. What if there's a global variable with the same name outside of the function's definition? If you never assign to that variable, it will never become local. You can use the global value within that function, and you can access its value just as you would normally expect. But what happens if you decide to assign to it at some point? That's a great question. Let me answer you with a story. See, a function starts as a code, but before you can run it, it always gets compiled. There's even dander for it. Dander code. And in this sense, assigning is a bit like yield. Whenever you assign within a function, the function is affected as a whole. The compiler takes all the variables in a function and sets each of them as either local, global, or free. If a variable is assigned to at least once, it becomes local and behaves as such even before the first assignment happened. Although it will error right in your face if you try to use it before the first assignment. Notice how this makes functions pretty safe to use with global variables. Unless the variable is mutable, like for example list_r. But ignoring that, there's no way for a function to modify a global. That is good. It means that it's much harder for some weird function that you wrote a year ago to mess up a value of a common global variable. It also makes using variables as constants a little bit more reliable in Python. But some of you smartasses already know that there's no rule in Python that you cannot break without any sweat. The same is true here. If you use a keyword global, you can use and assign to a global variable within a function. Keep in mind that this is something you should almost never do. If you want to keep a state for your function, you can use a class or a closure. If you really need a common global state, use a singleton and create a global class instance, then pass it to your functions as an argument. While it might seem like it's the same approach, it does clarify your intent behind the global value, but still, make sure that you actually need it. And if you need to modify a global variable, it's always better, as I say, to write a pure function, one that takes an argument and returns a value. Why is it better? Great question. It makes it much harder to sneak around a secret mutation in a function within a function. And pure functions are reusable. I've mentioned that variables can be global, local, or free. We've already talked about two of those kinds, but what about the third? Free variables are, in a way, very similar to globals. The difference is, where globals come from the global scope, free variables come from the scope that's outside of the local scope, but is not global. This scope can only arise if the function we're defining is defined within another function. It comes from mathematics. Free variables are the ones that are not bound to a particular formula, that is, ones that you have to provide from the outside. From that perspective, any variable that is not defined within a function or its parameters would be a free variable. But in Python, we exclude globals from that. Only functions can provide additional scopes, so to have variables that are neither local nor global, we need our function to be defined within a function. Okay, what is so special about those free variables? Nothing really, until you think about what happens if a function is accessed outside of the function it was defined in. Yeah, inception. Let's call the outer functions factories, and the inner functions closures. Coincidentally, this is actually what they're called. I'm not messing with you here. So, can that closure, remember the inside function, can that closure, how can it be called outside a factory? Many reasons. For starters, factories can and usually do return their functions. Functions are objects in Python. And if the factory has finished its run, you have to ask yourself one important thing. Where are the free variables stored? See? A tough one. If I asked you about globals, you know. Then they're globals, right? One dictionary per module. Maybe, just maybe, this is how closures store their free variables. I don't know. Well, I know. Yeah. They use a dunder, but not in this simple way. Let's see what this dunder looks like. There's a tuple with suspicious-looking objects called cells. Interesting. One for each free variable. If you look deeper, each of those cells has a cell contents attribute that contains the value of that variable. Whenever you run your function, it will first look at the local and closure variables, and then it will have a look at the globals. Also, you don't have to create your free variables before defining the function, just before running it. The same is true for globals. But why cells? Great question. Dunder globals didn't use cells. See, Dunder globals is a reference to a globals dict that is defined exactly once per every module. Every global in a module is stored in this globals dict. So when modifying a global, you only have to change it in one place. That is not the case for closures. Closures can access variables from multiple scopes at the same time. This can be a big problem. Let's say we do keep dicts, one for each scope. Now, every time you run a factory, you have to store all of its variables until the last closure it returned goes out of scope. Pretty wasteful, if you asked me. And if you wanted one scope per closure with only its personal variables, imagine having to update one of them. You'd have to go through each closure one by one until all those values get updated. And in terms of memory, it's still wasteful. Instead, closures keep free variables as cells. Those are special objects that contain a reference to a specific place in memory where the value is stored. That way, you store each variable's value exactly once per each factory run. And when you need to update it, you do it surgically, precisely where needed. Oh. Now those were some good closures. Remember this lesson when you want to create a simple local function to capture some local logic without having to repeatedly pass in the same arguments. Also when you need a simple state and don't want to create an entire class to manage it. And most importantly, when using lambdas and decorators. But that lesson is for another time. Subscribe.